Alright, welcome back my beautiful grade 10s to another video. Alright, we're going to be carrying on with functions today. Alright, and we're going to be doing parabola today. Alright, parabola. Alright, nice and quick. Alright, so just a quick introduction to parabola. Alright, so if you jump around, right, like if you go do long jump or high jump or whatever, alright, and you jump across, okay, you're standing here, there's a little oaky here, alright, and you jump across that pit, okay, and you land somewhere, okay, that is a parabola formation, okay, and if you throw, let's say this is Maniki, he throws a ball, he takes a ball, and he throws it up, eventually that ball's going to come down again, alright, okay, it's going to come back down again, and that is a parabola formation, alright, okay, so that's basically what a parabola is going to look like, alright. So if we get into this, alright, so that is what the parabola, a basic parabolic equation looks like, okay, basic equation for a parabola, alright, x squared, so that's something new, okay, from our straight line graph. Straight line graph just had x, or yeah, just had one singular x, right, now we've got an x squared, okay, now it's a little bit different to our straight line, okay, so now let's see how that differs, okay, so if I have -2 for x, I'm going to get 4 for y. So if I plug -2 in x over here, you're going to have -2 squared, okay, which is going to be 4. Alright, so that's my point. Remember, graphs are just points that you're subbing into an equation, okay, and you're getting points. Remember, that's all that graphs are. Okay, so if I get -2, I'm going to go to -2, and I'm going to go to 4, so I've got a dot over there. Alright, and if I plot this point over here, -1 and 1, go to -1 and I go to 1, there it is. Right, if I go to 0 and 0, there it is, my origin. Okay, I go to 1 and 1, it's over there. And then I go to 2 and 4, okay, 2 and 4. Right, by this point you should be able to plot these points quite easily, okay, you shouldn't be struggling with plotting points. Alright, so if I now look at this shape, okay, it's looking almost like a dome shape, right? Almost like some kind of curve shape over here. So if I connect these dots together, right, I'm going to do it as neatly as possible. Connect those dots, and I'm going to turn over there. Right, can you see the turning action? Right, I'm going to come up. Right, and notice how my parabola starts off at an angle, comes down, turns, and then it goes back up at an angle. All right, it doesn't come back to my y-axis like this, like some people draw it. Okay, please don't draw your parabolas like that. It goes off, okay, and it continues forever. All right, forever and ever upwards, forever and ever upwards. All right, so new things for a parabola. All right, firstly, it turns somewhere. Okay, it turns. We call this point, what do you think we call it? The turning point. Okay, mathematicians, we weren't very creative with language, right? So we just call it the turning point, right? Because it's where it turns, all right? And then also it carries on forever, forever, all right? And we also have an axis of symmetry, okay? Axis of symmetry going straight down, right? Because on the y-axis, okay, if I had to put a ruler, let's say I put a ruler down here, okay, draw a ruler. Right, on either side of that ruler, okay, my graph is the same on either side, okay? So my axis of symmetry goes through my turning point, so whatever my x value for my turning point is, that will be the equation of my axis of symmetry, okay? So that's all the axis of symmetry is, just means it's the same on both sides, okay? Right, nice and simple there. Right, so if you really want to, you can label that. So my x value there is 0 and my y value there is 0. That's my origin. Okay, therefore my axis of symmetry for this parabola is going to be x is equal to 0. Okay, so it's always my x value, axis of symmetry. Okay, nice and simple. All right, okay, there's no asymptotes, none of that. We're going to get to asymptotes later for hyperbola and exponential functions. Okay, so moving on. All right, so that's what it looks like. Okay, that's a neater drawing. I used a program to plot that. Okay, it looks a little bit neater. So it turns. Please notice that it turns and it goes away. It goes away. It doesn't come towards the y-axis. Okay, it keeps going away. Keeps going away. All right. So now, if I tell you to go and draw this, okay, I don't want you to draw it. I just want you to visualize what's happening. Okay. So we've got a normal x squared. Okay. Remember, this is the graph. Y is equal to x squared. Okay. So if this is y equals x squared, what do you think y is equal to x squared minus 1? What do you think that's going to look like? Give you a few minutes, a few seconds to think about it. All right. It's just this graph, this exact graph, moved down 1 unit. Okay. Because we're moving it down minus 1. Okay. Going down 1 unit. So all these points are going to come down 1 unit. Okay. And it's going to form something that looks like that. All right. So the green one is x squared. So let me actually just cover this up so you guys don't get confused. Cover this up for now. Okay. So the green graph, okay, is my y is equal to x squared minus 1. Okay. And that's what it looks like. Can you see it's just the blue graph shifted down 1 unit? Can you guys all see that? Okay. So all these points just moved down 1 unit. Move down 1 unit. Move down. Move down. Move down. From the blue to the green. 1 unit down. Alright? So now, if you go and visualize this now, y is equal to x squared plus 1. What do you think happened to the blue graph? Okay, the blue one. Okay, it just went up 1 unit. So all these dots that I plotted just go up 1 unit. Up 1 unit. Up 1 unit. Up 1. Up 1. Up 1. And I'm going to get a graph that looks like this. Okay, so there's my orange one. That's x squared plus 1. Okay, the blue one is just x squared. Alright. And then the green one over here is x squared minus 1. Okay, can you see that it's just a normal blue graph? Either plus 1 to the orange or minus 1 down to the green. Okay, nothing difficult about that. It's just the same graph moving up or down. That's it. Okay, and that's how difficult it's going to get in grade 10. Alright, in grade 11 though, we're going to move from side to side, we're going to move left and right, and we're going to move away from the y-axis. But in grade 10, we're going to keep it nice and simple, and we're just going to move up and down for now. Okay, just to get you used to the parabola. Okay, so if we move on, all right, let's see what happens when we change the gradient, okay, of this function. Okay, so the gradient, so just so you guys know, the gradient is going to be, okay, for my normal blue graph there, my y is equal to x squared. The gradient is going to be whatever's in front of my x squared. Okay, in this case it's just 1. Okay, so what happens if I change whatever's in front of my x squared? Okay, so that's what this is going to be doing now. Okay, so if I move here, right, so that's my normal function, right, my normal basic parabola. Okay, x squared, that's 1x squared. So what happens if I change that 1? Okay, and I make it, let's say I make it bigger. All right, so if I tell you to go and draw, or let's say make it smaller, sorry. All right, and I say go and draw that, what do you think is going to happen? All right, so if you think of a straight line, let's go back to straight lines quickly. All right, just to visualize quickly straight lines. All right, so if I drew a straight line and I did this, all right, is that steep? Is that a steep line or a not so steep line? That's a steep line, all right? That means a big gradient, okay? That means a big gradient. But if I drew, let's say I drew that line like this, is that a steep or not so steep line? That's not steep. And can you see that this one is a lot closer to my x-axis than the other one, all right? This one, if I draw it like this, nice and steep, okay, that's quite far. It's got a further distance to travel to get back to my x-axis. So the gradient is bigger, right? And the gradient is smaller. Okay, we're getting closer to the x-axis. Okay, so that's going to be the same for my parabola. Exactly the same. All right, so if I've got a smaller gradient, okay, think back to the straight lines I just drew. Okay, did I go closer to the x-axis or further away with a smaller gradient? Closer to the x-axis. Okay, so if I look here, there it is. Right, so my parabola. Okay, can you see now that the orange one is closer to my x-axis than my blue one. Right, the blue one has a further distance to travel to get to my x-axis than my orange one. Okay, can you see that? Right, now what do you expect to happen if I increase my gradient? Alright, am I going to get further away from the x-axis or closer to the x-axis? I'm going to get further away. So where's the green one? What do you expect the green one to look like? Is it going to be inside here somewhere or outside here? It's going to be inside here somewhere. Alright, it's because it's going to be further away than the blue one. Okay, so if I write this all out, right, go to the next slide. There it is, there's the green one. Okay, can you see that that is a lot further away from my x-axis than my blue one or my orange one? Okay, can you see that? Can you see the different distances there? Alright, so that's all the gradient does. So either, if you want to remember, big gradient, okay, means thin, okay, thin graph. Alright, smaller gradient, okay, means fat graph. Okay, it's getting fatter if you want to say it like that. Okay, right. So, what about a negative gradient? Alright, so if I go back to straight lines, okay, straight line, right, there's my Cartesian plane, and if I draw a line like this, alright, what gradient is this? This is a positive gradient. Alright, now if I draw a straight line like this, right, that we all know is a negative gradient. Okay, can you see that they are different? They're not the same. Something happened. Okay, I flipped this graph. Okay, I flipped it on my x-axis. So if I put my line over here, let's put my my ruler over there. Okay, so if I take this part over here and I flip it upwards, I'm going to get this part over here. And if I take this part over here and I flip it downwards, okay, on my ruler, I flip it, and it's going to look like that. It's going to go down here. It's going to look like that. Okay, so that's all that's happening with the negative gradient. And that happens for all the graphs. Okay, we're flipping this graph on my x-axis. Okay, so this part is going to go up, becomes like that. And this part's going to go down, and it's going to look like that. Okay, nice and easy. Alright, so what do you expect? Of course, okay, so my normal parabola, basic parabola, looks like this. Okay, looks like that. Okay, so I'm going to take my ruler, okay, put it on my x-axis, okay, and I'm just going to flip it downwards. Okay, I'm going to flip it over. Alright, flip it over the ruler, and it looks like it's sad. Okay, so we've got smiley face, and we've got frowny face. Okay, so negative, if you want to remember it, negative means, okay, you're going to be sad, you're going to be grumpy, okay, you're going to have a frown on your face. But when you're positive, okay, you're going to have a smile, you're going to be happy, you're going to have a smiley face parabola. Okay, alright. Okay, moving on. So now let's imagine what the parabola is going to look like. Alright, so before we carry on, I just want you guys to get to imagining stuff in your brains, alright? Just imagining before you actually start doing stuff. Okay, so if I look at this, so now we already know what the basic parabola looks like. Okay, we know y equals x squared. If I had to say y equals x squared to you, alright, you'd think of, what are you going to think of? You're going to think of your Cartesian plane. Nice. Okay, remember this is just going to be a rough sketch in your brain. Alright, x squared. Okay, for parabola, we always talk about the turning point. Alright, so where's my turning point going to be? Can you remember? Yeah, it's going to turn here in the middle. Alright, and we're going to go down and we're going to turn. Alright, and that's what my basic parabola looks like. Basic. Alright, now if I look at this one, we say it's negative x squared. How do you think that's going to look? I'm going to draw my Cartesian plane, nice and rough. Right, where's my turning point going to be? Where am I going to turn? I'm turning here. Right, it's turning at the origin, and it's an upside down parabola. Okay, sad face. Okay, and it looks sort of like that. Okay, alright, nice rough sketch. Okay, in my brain, I can visualize. Okay, I'm going to draw my Cartesian plane, nice lightly. Okay, roughly. Right, x squared plus 1. Right, what do you think is going to happen there? Where am I turning? Where's my graph turning? It's turning on on 1, remember, okay, because x squared turns on the origin, but if I move it up 1, right, the whole graph is going to come up 1 unit. Okay, so that means it's going to turn at 1. With me? Alright, so look at the next one. Alright, now I've got negative x squared, okay, but I'm minusing 1. So is the graph going up or down? It's going down. Alright, so there's my Cartesian plane. Alright, I'm going to turn at negative 1, okay, wherever that is, and I'm going to be a frowny face. Right, so I hope you guys can all visualize those. Alright, nice and easy. Now, what I want you guys to do is to do this one quickly. Let's think about it. Alright, so we're going to do Cartesian plane again. Alright, we've got a negative 2, so it's going to be a little bit thinner. Remember, big gradient means thin. Right, and we know it's negative, so it's going to be frowny face. And am I adding something? Am I minusing something? No, I'm not. So where am I turning? I'm turning at the origin. Alright, good. So we're going to have frowny face. It's going to be a little bit thinner than the other ones. Okay, nice and thin. Alright, there we go. And that's what it's going to basically look like. Okay, nice rough sketch of my parabola. Okay, so I hope you guys can all imagine those. Okay, and let's look at this one. Okay, so it's going to be a little bit fatter than the other ones. Alright, and we know it's a smiley face parabola because it's positive. And we know it's going to turn where? Where is it turning? Am I adding anything? No, I'm not. So it's going to turn at the origin. Alright, so it's going to be a bit fatter. Alright, make it nice and fat. There we go. Okay, nice rough sketch. Okay, doesn't really matter what it actually looks like. Okay, it's just nice and rough. Okay, alright, let's see. Right, so now what can we observe about all these parabolas that we just thought of? Okay, so if I look at all of these, what is common in all of these? Okay, some are upside down, some are right way up, right? Some are fat, some are thin. But what is something that's common in all of these? Okay, and I'm going to make a specific point. How many times are these specific parabolas touching the x-axis? So here's my x-axis, my y-axis. How many times is this one cutting the x-axis? Once. Alright, can you see? There's nothing being added. Okay, there's nothing being added. Okay, whenever nothing is being added, okay, let's look at it. Nothing's being added here. Where's it cutting? Oh, at the origin. Alright, over here, something's being added. So where's it turning? Okay, where's it cutting my y-axis? At whatever I'm adding there, it's adding 1. Right, so it's turning at 1. Right, and how many times is it cutting my x-axis? 0 times. So it's not cutting at all my x-axis. Right, everything is above the x-axis there. Right, now if I look at the next one, alright, we're turning at negative 1. Whatever I'm adding there, that's going to be my turning point. Right, and it's negative. And am I cutting my x-axis at all? No, I'm not cutting at my x-axis at all. Alright, can you guys see that? Right, look at the next one. Okay, I'm not adding anything here. Okay, so where do you think the turning point is going to be? At 0. Okay, 0, 0. Right, and it's upside down. Right, and it's cutting my x-axis once. Okay, cutting my x-axis once. And if I look at this one, okay, I'm not adding anything here. Alright, so that means my turning point is going to be at 0, 0. Right, and I'm cutting my x-axis once. Alright, so that's what we can observe about those parabolas. Now, let's imagine these ones. Alright, so I'm going to draw a Cartesian plane. Draw it nice. Okay, and if I imagine what that looks like, okay, if I take a normal parabola, okay, normal x squared, okay, I know what that looks like. And if I'm minus 1, is my normal x squared going up or down? It's going down 1 unit. Okay, so how many times am I going to cut the x-axis? Twice. Good. Right, so I'm going to have a turning point at negative 1. Right, and I know it's a smiley face, and I'm going to turn on that point and smile. Right, so I've got 2 points here that it's cutting, okay, on my x-axis. Right, can you guys see that? Alright, so whatever I'm adding there, okay, that's going to be my turning point. Alright, and if I visualize this one, x squared minus 4, okay, draw my Cartesian plane quickly. Alright, so I've got my y-axis, I've got my x-axis. If Alright, so I've got a normal x squared, and I'm minusing 4 units. Am I going up or down? I'm going down 4 units, okay? So I'm going to go down to -4. Right, and what is that point? It's my special point of a parabola, turning point. Alright, and I know it's a smiley face, so I'm going to go here. I'm going to turn there, and I'm going to come back up. Okay, you with me? Alright, nice and easy. Okay, alright, so moving on to the next one. If I look at -x squared plus 4, okay, draw my Cartesian plane quickly. Nice and easy. We're going to do this nice and quick because I think you guys are getting it. Alright, normal -x squared. Okay, it's a frowny face, and I'm plussing 4 units. So my turning point is going to be at 4. Okay, and it's a frowny face. Alright, so how many times am I cutting x-axis? Twice. Okay, can you guys see that? Alright, over here again. Okay, Cartesian plane quick. Okay, turning point is going to be at 1. It's a frowny face, so I'm going to turn over there, frowny face, downwards. How many times is it cutting? It's cutting twice. Okay, can you guys imagine that? Okay, so what can we observe about these parabolas now? Can you guys see that these ones cut the x-axis twice, 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 right? And also twice. Right, so now we've learned how to visualize them. Alright, so now let's use that. Let's not lose that. Let's use it, not lose it. Alright, and let's use that in how we're going to find the equation and how we're going to sketch our parabolas. Because we're going to have to eventually find the equation and also sketch our parabolas. Okay, as we have done with our straight line. Okay, so whenever I'm finding the equation of any graph, what do I have to start with first? I can't just start. I need somewhere that I can start with. I need something I can start with. Yes, I always start with the general equation. Okay, so now let's look at that. So for a parabola, okay, we've got y is equal to ax squared plus c. Okay, so it looks almost the same as your straight line. Okay, so your straight line is equal to y equals mx plus c. That's my straight line. Okay, that's a straight line graph. Alright, so can you see that I've got a gradient and I've got a c value? Okay, and my c value is my y-intercept as well for my straight line. Alright, and I've got a gradient. So it's the same with parabola. The only thing that's different is this x squared. Right, can you see in the straight line I've got an x, but here in the parabola I've got an x squared. Okay, still got a gradient, still have my y-intercept, but also in the parabola, the c value is not only the y-intercept, it's also my, what's its special point of a parabola that we've learned? Where it turns, alright, my turning point. Okay, turning point. Okay, so my c value can be two things, my y-intercept and my turning point. Okay, of my parabola. Okay, so if I look at this and I say we want to go find the equation of this parabola. Okay, so firstly, where do I start? I always start with my general equation. Okay, so y is equal to ax squared plus c. Okay, so my c value, let's go find that. Okay, because I know what that is. My c value is either my y-intercept, okay, or my turning point. Okay, it's actually both the same thing. Okay, it's not either or, they're linked. It's the same thing. Okay, because if I go to my turning point, that's where it's cutting my y-axis over there. Okay, so my turning point is at 0 and 0. Okay, can you guys see that? 0, 0. Alright, so what is my c value there? C is going to be 0. Okay, so now let's substitute this c value in this equation. Let's see what we have left. Ax squared. Alright, plus 0. I don't have to write the 0 because it's nothing. Alright, now I want to go look for a, my gradient. Remember, same thing with straight line. I'm looking for c and I'm looking for a. Those two variables. I'm looking for those two. So I've got my c value, just found it. Now I'm looking for a. Now what do I need to find a? Can you see I've got an x and a y here? Right? So if I have the value, the numerical value, so a number that represents x and y, do you agree that I can go and find a? Yes, of course I can. Alright, so in order to go and find what x and y is, what do I have to go do? I have to go find a point in the graph. So they gave me this point over here. Okay, so that is 1 and 1. X is 1, y is 1. Okay, so if I put this in my equation over here, my x value, okay, is my first one, and my y value is the second one. So my x value is going to be 1 squared, okay, and my y value there is going to be 1. Right, so a times 1 squared is just a, okay, and 1 stays 1. Okay, so my a, which is my gradient, is 1. So what is the equation of this parabola? Y is equal to 1x squared, which is just x squared, plus 0. And there's my equation of the parabola. Nice and easy, guys. Okay, not too difficult. Okay, so the first thing we did, we're going to go look for our turning point, my c value. Substituted that c value in, see what I have left, right? And then I went to go find a point on my graph to get me my x and y, and then I found my gradient, and then I just substituted a and c into my general equation. Okay, nice and easy. Right, let's look at the next one. Okay, so to find the general equation, just to find the equation of any graph, I always start with the general equation. Okay, all right, y equals ax squared plus c. All right, my c value tells me what? My turning point or my y-intercept, okay, which is the same thing in this case. So c is equal to my 1. All right. All right, so let's go substitute that in. Y is equal to ax squared plus 1. All right, and how do I go and find a now? I need x and I need y. All right, so I need x and I need y. All right, so I'm going to go label this point. This is -1 and 2. All right, let's go substitute that into the equation. All right, I've got a, and my x is -1 squared plus 1. And my y value there is 2. Right, so now let's go solve for a, normal equation. Right, so I've got a times -1 squared, which is just a, plus 1 equals 2. Therefore, a is equal to, take the 1 over, and a is equal to 1. Therefore, my equation of this parabola is going to be y is equal to x squared plus 1. Okay, so my a value there is 1, and my c value is also 1. Okay, and there's my equation of the parabola. Okay, nice and easy. Okay, moving on to the next one. Okay, so if I look at this, okay, I've got an upside down parabola this time. Okay, so I'm not going to fear. So do the same thing, y is equal to a x squared plus c. Right, that c value is going to tell me in grade 10. Right, because in grade 11 you're going to shift left and right. Okay, so but just forget about that for now. Right, just so you know, only in grade 10 will my c value be my turning point. Okay, so my turning point is going to be my c value, okay, in grade 10, which that means c is equal to -1. Alright, and let's go substitute that in. Y is equal to a x squared minus 1. Alright, in order to find a, I need x and y. So x there is 1, y is -3. Alright, and let's go substitute that in. Okay, so I've got a, and I've got 1 squared minus 1, and I've got y, which is -3 there. Alright, a times 1 squared is just a, minus 1 minus 3. Okay, and take the 1 over, it becomes -3 plus 1, which is -2, and a. Therefore, the equation of that parabola is going to be -2 x squared minus 1. Okay, and that's my equation of that parabola. Okay, hoping that's making sense, nice and easy. Okay, let's look at the next one. Alright, so over here, right, I always start with my general equation. Good, so y is equal to a x squared plus c. Right, that c value tells me my turning point. Alright, so that c value, okay, my turning point there is -1. Alright, substitute that in. I've got y is equal to a x squared minus 1. Okay, I need an x and I need a y. where am I going to get my x and y from? Right, so they don't necessarily give me a point here, right? But I can see that that cuts my x-axis at 1. Alright, so I have a point, right? I've got an x value of 1, and my y value is 0 there. Okay, so let's plot that in there. Okay, so I've got an x value of 1, so 1 squared minus 1, and my y value there, 0. Okay, so I substituted that point in there. Okay, so a, it's going to give me, so a times 1 squared is just a, minus 1 and 0. Take the 1 over, a is equal to 1. Right, so my my equation of this parabola is going to be y is equal to 1x squared minus 1. Okay, and there's my equation for that parabola. Okay, so nice and easy, guys. I hope that's making sense. Alright, I think this is the last example, right, of finding the equation. So whenever I find the equation, I have to first do my general equation. So y is equal to ax squared plus c. Okay, so if I look at that, we know that the c value is my turning point, which is at 1. C is 1. Okay, we know it's going to be upside down. Okay, so I'm expecting a negative gradient. Okay, so let's substitute y is equal to ax squared plus 1. Right, let's go find a point. I see I've got a point there of 1 and 0. Okay, because cutting my x-axis there at 1 and at 0. Okay, substitute that point in there. Alright, and we're going to have 0 equals a, oh, 2 equal signs there, not bad, equals a, and 1 squared plus 1, okay, which is just a, plus 1 equals 0, take the 1 over, negative 1a. Therefore, my equation is y is equal to negative x squared plus 1. Very good. Okay, nice and easy. Okay, hoping that's quite easy for you guys now. Alright, so now let's go and sketch some parabolas. Okay, so after we're done sketching, I think we've got 4 examples here, and that will be the end of the video. Okay, so thanks for staying for so long. I know it's a long video, okay, but there's a lot to get through here for parabola. Okay, so if you made it to this point, well done. Okay, so let's go sketch some parabolas. Alright, so we are going to choose a point when my c value is equal to 0. So what does that mean? It's when what is my c value again? My turning point. So it's when the turning point, okay, the turning point of my parabola, okay, is at 0. So it's when it's cutting once my x-axis. Alright, so do you remember when I told you to go in the beginning of the video, I said we're going to visualize? This is where this is going to be handy. That's why I told you to visualize. Alright, so I hope you can visualize these parabolas. Alright, so, and when the parabola is completely above or completely below the x-axis. Okay, so meaning this, remember, so when we're completely above the x-axis, we're not cutting at all, or we're completely below. Right, we're not cutting at all. We're not cutting the x-axis at all here. Alright, that is when we are going to choose a point. The first time ever we're going to take control of mathematics and we're going to choose whatever we want. Okay, viva to the people. Alright, so if you look at this. Alright, so now let's visualize first. Before I sketch, I need to visualize first. Okay, visualize. Let's look. So, we don't have a c value. That means what? That I'm going to cut at my origin. Good. Alright, and I'm going to turn here. I'm turning here. That's going to be my turning point at 0, 0. Alright, now in order to draw a parabola, okay, in order to draw a parabola, I need my turning point and I need 2 other points. Alright, I need 3 points for a parabola. Okay, so I need to draw 3 points. So I need to substitute in 2 points. I need to come up with 2 other points. So I've got 1. Alright, now pick any x value. Any x value. Alright, preferably we want to pick a low, nice and easy x value. Alright, but you can choose anyone you want. I'm going to choose 1 because it's nice and easy. I'm just going to choose 1. So for my point 1, my first point, okay, I'm going to sub in x is 1. Okay, so y is equal to 1 squared. Okay, so I substitute, I picked that out of the sky. That's my own value that I made up. All right, I'm going to take that, I'm going to put it in there. Okay, that means y is going to be 1. You with me? Okay, so what is the point that I just created? Okay, coordinate form. Okay, what is the x value that I chose? I chose this x value. I chose 1. And what did I end up with y when I chose 1 for x? I got 1 for y. So that's my first point there. Right, point 1. Right, let's go plot it. 1, 1. Okay. Then for my second point, okay, this is going to be the easiest point to choose. All right, because I'm just going to choose the reflection, okay, the opposite of 1, which is -1, the reflection. Okay, we call it the reflection. Okay, so for my point 2, okay, we're just going to choose the reflection of what I chose for the first one. Okay, so I don't even have to do any thinking. So y is equal to -1 this time. Okay, for x. Okay, so I chose 1 for x. I'm just going to choose negative. Okay, and what is -1 squared? It's just 1. All right, so what is the point? Okay, what is the x value that I used? I used -1. And what did I use for y? I used 1. So let's go plot that now. Let's go plot that point. Here we go. Okay, and we've got -1 and 1. Okay, and let's go plot this one, 1 and 1. Alright, now I've got 3 dots. Awesome, now I can just join them. I know it's a smiley face. It's going to go through that dot. It's going to turn at the origin, and it's going to go through that point and keep going up. Alright, okay, and I'm going away from my y-axis. Okay, away from it. Can you see it's a curve? Okay, I'm slanting, curving, and I'm slanting again. Okay, with me there. Right, so again, whenever my graph is completely above, completely below, or touching once, okay, am I going to use this point method? Okay, I'm going to pull out some point from the sky, okay, and I'm going to put that in there, substitute, and I'm going to get my points. Okay, so let's look at the next one. Let's visualize quickly. All right, do I have a C value? No. Okay, so if I don't have a C value, where am I turning? Turning at the origin. Fantastic. All right, I'm turning at the origin, 0 and 0. All right, let me actually put this point on the other side. I know it's going down. Okay, so 0 and 0. All right, so I know it's going to touch the x-axis once. Okay, so I'm going to pick points, pull points out from the sky. I'm going to use 1 again. Okay, just because it's nice and easy to substitute 1 in. Okay, so for my first point, I'm going to substitute 1 in for x. Okay, so I've got that. So I'm going to just substitute it in 1 there. Okay, always use your brackets. And that's going to give me -2. Right, so the point that I made there is, what is the x value that I used? I used 1. I picked that value, and it gave me -2. Let's go plot that before I forget. So I go to 1 and I go to -2. There it is. Let me label it before I forget as well. Right. Then for my second point, I'm just going to use the reflection of what I chose already. Right. All right. So y is equal to -2, and I'm going to choose -1 this time. So this is the reflection of what I chose before. Okay. And that's also going to give me -2 for y. All right. And the point that I used was -1 and -2. Right, let's go plot that. -1, -2. Right, I've got 3 dots. Right, and that's -1 and -2. And now I can just put a frowny face there, connect those dots, turn over there, come down again, and there we go. Okay, and sorry, I forgot to put my name of my graph for this one. Y equals x squared. And over here as well, y is equal to -2x squared. Okay, happy with that, guys? Okay, so let's look at the other ones. All right, so now I'm adding something. Okay, so now let's visualize. Okay, what is this going to look like? Okay, if I visualize it. Okay, normal x squared plus 1, completely above my x-axis, completely above. All right, so again, when it's completely above or touching once, I'm pulling values out of the sky. So 0.1. Alright, point 1. I'm going to substitute 1 in because it's nice and easy. Y is equal to 1 squared plus 1, which is 2. Alright, so let's go plot that. Alright, so we've got 1 for x and 2 for y. We'll go 1 and 2. Alright, and let's label that 1 and 2. Alright, and then I'm going to use the reflection for point 2. Alright, and y is equal to negative 1 squared plus 1. And that's also going to give me 2. So my point there is negative 1 and 2. Let's go plot that. Negative 1 and 2. Negative 1, 2. Alright, but I'm missing a point. What is my other point going to be? My C value. Yeah, where it cuts my y-axis, or my turning point in this case. Alright, so my turning point. So we know it's going to be a smiley face. So I'm coming down slanted and I'm turning over there and I'm going back up. Oh, going back up there. And then I name my graph. Y is equal to x squared plus 1. Okay. And then the last example for this. Right, for these examples. Alright. So again, I'm going to visualize. Okay, is it above, completely below, or is it touching once? Tell me quickly. It's completely below. Very good. Alright, so it's going to look something like this. Completely below. Right, my turning point is at negative 1, and it's negative, frowny face. Okay, so I'm going to pick points. Okay, so point 1 there. Right, I'm going to pick 1 again. Okay, pick things up from the sky. 1 squared minus 1. Okay, and that's going to give me negative 2 for y. So my point there is 1 and negative 2. So 1 and negative 2 there. Right, so we've got 1 and negative 2. Right, and then I'm going to use my reflection for point 2. Right, so y is equal to negative 1 squared minus 1. That's also going to give me negative 2 for y. Right, and that's negative 1, negative 2. Negative 1, negative 2, there we go. There's my point. Negative 1, negative 2. Alright, and then I'm forgetting my last point. What is my last point going to be? My turning point, or my y-intercept. Okay, so there it is, negative 1. Okay, and then I know it's going to be a frowny face as well. Turn and all the way down. Okay, alright, and then I must also not forget to label this. Y is equal to negative x squared minus 1. Okay. Alright, I'm hoping that's making sense to you guys. Alright, so now let's deal with the cases. Let's draw the specific parabola, alright, where it's now above, so not above, where it's touching the x-axis twice. Alright, so all these examples that we drew, okay, we're only touching once or not at all. Right, so that's when you're just pulling points out from the sky. So now, if we know that it's going to touch the x-axis more than once, so twice, right? We need to go and find where it cuts the x-axis. Right, we need to go find that specific point. Okay, so now let's go see how we're going to do this. Right, so before I say anything, before we go and look at the Cartesian plane, well, let's actually go look at the Cartesian plane. It's going to be better. Right, so let's visualize this quickly. X squared minus 1. What is it looking like? Okay, it's going to look something like this. Okay, smiley face, cutting there at negative 1 and cutting twice. Okay, my x-axis. Okay, but I don't know what those points are. Alright, I need to go find those points. Alright, so remembering from straight lines, right, on my x-axis, what is one value that I will always know on my x-axis? I know that y is equal to 0. So if I'm finding my x-intercepts, right, where it intercepts with my x-axis, I know that y is equal to 0. Alright, so I can just substitute y in there. 0 equals x squared minus 1. Alright, and what is this? NB this. Alright, because what is this? This is a difference of two squares. Alright, let's go do that quickly. Okay, I'm not going to take too long in explaining that. That's going to be x minus 1, x plus 1. Right? And what is this? This is a quadratic equation example. Alright, it's coming together. Right? Why did we do quadratic equations, sir? Because this is why. Alright, so when I've got bracket times bracket equals 0, we know that the one bracket equals 0, or the other bracket equals 0. Alright, so that means x is 1 or x is negative 1. Alright, so what's the point for if x is 1? X is 1. Y? What y value did I substitute in the beginning? Y is 0. Okay, or what is the other point here? X is negative 1. Or what is the y value? 0. Oh, there's my x-intercepts, guys. There's the 2 points that I was looking for. Alright, so let's go put all the points that I know on the graph and let's see what happens. Right, so firstly, this negative 1 is my turning point, or my y-intercept, so it's over there. Alright, and let's go plot these 2 points. So let's plot the first one, 1 and 0. So I go to 1, I go to 0. I can label that 1 and 0. Alright, and let's label this one negative 1 and 0. Negative 1 and 0. Negative 1 and 0. Right? And I've got 3 dots. Oh, that's perfect. Okay, I can draw my parabola. Now it's going to be smiley face, turn, and come up again. Right, and then I must label there y is equal to x squared minus 1. Okay, I'm hoping that's making sense. Alright, so the difference here now is I'm finding my x-intercepts. Alright, so that's why the visualization thing is very important. Okay, so when my parabola is not touching the x-axis at all, or touching only once, what method am I using? I'm pulling points out of the sky. Alright, I'm doing my own thing. Alright, taking control. Alright, but when it cuts twice, my x-axis, when it touches twice, I need to go and find where those points are on my x-axis, and those are my x-intercepts, where it intercepts with my x-axis. And on my x-axis, I know that the y value is always 0. Substitute, difference of two squares, solve for x, boom, boom, get my points, plot it, skadoosh. You know what I mean? Okay, so let's do one more example of this, and then we can call it a day, ladies and gents. Okay, so x squared minus 4. Fantastic. All right, so I know visualizing. All right, I know it's going to be cutting twice. All right, and my turning point is going to be negative 4. It's going to cut twice. I need to go find those points, and those are my x-intercepts. To find x-intercept, I know that y is 0. Alright. And if y is 0, I'm going to substitute 0 equals x squared minus 4. Right, I know that that is a difference of two squares, always. Alright, always. It's always going to be a difference of two squares. Right, so I've got x minus 2, x plus 2, 0. Okay, and that means that x minus 2 is equal to 0. Or x plus 2 is equal to 0, x is equal to 2, x is equal to negative 1. Oh, sorry, negative 2, my bad. Okay, 2 or negative 2. Therefore, the point, the coordinate that I'm forming there, coordinate. Okay, so my x value there is 2. And what y value did I use from the beginning here? 0. Alright, x here is negative 2. And what y value did I use? 0. Alright, and there's my two x-intercepts. Alright, let's go plot those. So I've got negative 2 and 0. And I've got positive 2 and 0. Okay, we'll put those in. 2 and 0. Negative 2 and 0. Alright, and I'm missing one point. Where am I going to get the other point from? My c value, okay, which is my turning point. And it's going to be at negative 4 there. Okay, and I know it's going to be a smiley face. Right, so I'm going to come down at a slant, and I'm going to turn, and I'm going to come back up again, going through that point, all the way up, and put my arrows there, so it keeps going up, it never stops. Okay, and y is equal to x squared minus 4. Alright, I actually think there's one more example. Yes. Alright, so let's try this one. Go do it by yourself quickly. Pause the video. You've made it this far, you might as well do it. Alright, so I assume you've done it already. Let's go through it. Alright, so to visualize quickly, a Cartesian plane, there it is. Alright, we know it's going to be his frowny face, and we know it went up 4 units. Okay, so frowny face, up 4 units, turning point at 4, and frowny face, turn there and down. Cutting twice. Alright, when it cuts twice, I know I'm finding my x-intercepts. My x-intercept when y is equal to 0. Alright, so 0 equals negative x squared plus 4. Alright, but there's something different here than in the previous two. Alright, can you see that my x squared is negative? Alright, so in these ones, I've got positive x squared. Alright, but here I've got a negative x squared now. Right, so to get that back to positive, I need to do something. Right? Either, there's two ways you can do this. Okay? So, you can either divide everything by negative 1. I mean everything. So I'm dividing this by negative 1, and the 4 by negative 1, and the 0 by negative 1. Okay? So, if I do that, I'm going to get 0 this side, because 0 divided by anything is 0. I'm going to get x squared, and then minus 4. Okay, that's when I'm dividing everything by negative 1. Or, what I can do as well is I can just take everything over to the other side. So if I take x squared over, I'm going to get x squared, positive. If I take the 4 over, I'm going to get negative 4 equals 0. Now there's nothing on my right hand side. Now there's everything on my left hand side. Okay, so I just took it over and it's the same thing. Okay, so whichever one you prefer. Okay, most students prefer this way because they don't like dividing by negatives. And sometimes they forget. So I would assume that this is the easier one. Alright, and I would recommend it. Okay, so now I've got a difference of 2 squares now. Here's my difference of 2 squares. So I've got x minus 2, x plus 2 equals 0. Okay, therefore x is equal to 2. X is equal to negative 2, 4, right? So I just skipped a step, that's fine, you can go straight to the answer here, okay, just by the way. Alright, so the point there is 2 and 0, and the point here is negative 2 and 0, and there's my two x-intercepts. Right, so I go to 2 and 0, so 2 and 0 there, right, 2 and 0, and I go to negative 2 and 0. Okay, and I go up to 4. Okay, and I know that that's going to be a frowny face. Right, and turn and all the way down. Okay, right, and I'm going to label that y is equal to negative x squared plus 4. Alright, grade 10s, I know this was a very long video, okay, but there was a lot of stuff to cover in parabola. Right, it's going to be the same for hyperbola, so just bear with me. Alright, and I hope that this video has helped you guys understand the parabola a little bit more, and I hope it helps with your future tests and your exams. Okay, alright, I will be doing other videos later on once I've done all the videos. Alright, I'm going to do more complex videos on how to sketch parabolas when there's certain things that happen, so just be on a lookout for that. Please guys, like and subscribe, and I hope this helped. Okay, cool.